Hello, I'm James Halliday, or Substack from the internet, and I've written hundreds of NPM packages, and I've spent a really long time on the command line, and I'd like to just brain dump everything that I know about computers so that you can know it too. In this course, we're going to be using Bash, which is a shell that you'll find pretty much everywhere, on phones, on servers, on Linux laptops. You'll learn about the utilities that are already installed on your system. You'll learn how to combine those utilities to create your own commands, and you'll be able to write your own custom scripts. Regular expressions are a common feature in just about every programming language. They might look scary, but they're composed of very simple rules. In this course, we'll cover features like character classes, capture groups, and anchoring so that you can process and manipulate text. Vim is a powerful text editor that you can use to edit source code, all while keeping your fingers on the keys. With Vim, you can use the same familiar development that you use locally on remote servers. In this course, we'll cover basic usage as well as some advanced tricks. I hope you find this information really useful as you join me on this journey through cyberspace. Here's another fun command. It's called curl. So curl will take any URL. So like here's the Project Gutenberg from Moby Dick that I've been using for my example. And you can get it from the notes, or if someone could paste it into the chat, that would be handy.
I just did, and I was playing with this, and I had to add a -- compressed flag because it was coming back gzipped.
Oh yeah, well, there's another command that we can do with a pipe that might even be a better example, but yeah, okay. Yeah, I think when I last did this workshop, it wasn't gzipped by default. So anyways, if we do curl with the URL, what the curl command does is it loads the URL and it prints the contents to standard out of whatever URL you've done. And I recommend to use the -s flag with curl because by default curl like prints a progress bar that can kind of get in your way sometimes. So if I do curl -s and give it a URL like a text file or whatever kind of file you want, then it's going to print the contents to standard out, which happens to be compressed with gzip. So there's a program that should be already installed on your system called gunzip, oh right, so if you happen to have done the curl command and your terminal looks all weird like this, and if you type and it looks like gibberish, you can fix it by typing reset. And now your terminal should be better. Okay, so there's a program called gunzip, which is spelled like this. And that will read from standard input, gzipped compressed data, and it will write uncompressed data to standard out. So we can combine these existing tools to do something that we want. So here we go. And now I see the uncompressed output. Pretty sweet. All right. So we can do some other fun things. I'm going to cover this more in the regular expression section later, but here I have a little program using sed, which replaces all white space with new lines. So if there's something like a space, it's going to turn that into a new line. And this is really useful because it means that every word will be on its own line. So we can start to do things like filter those lines or count the number of lines, for example. So if I add that little bit at the end, of my program, then now I see every word gets its own line. And I can use another program called Grep that's going to filter the output. So suppose that I only want to see lines that contain whale. It's Moby Dick, so of course there's a lot of them. Sometimes whale is at the beginning of a sentence, so like a capital W. There's another flag that you can pass to grep that does case-insensitive matching, -i, which you can put in the middle or you can put it at the end because the order doesn't matter. So if I want to see all of the instances of the word whale, lowercase or uppercase, we curl this text file which is compressed, then we gunzip it, and then we turn all of the white space into new lines so that every word is on its own line. And then we search for all of the lines that contain the word whale, like that. And now we can pipe that to the wc-l command to know how many times in Moby Dick the word whale appears, which happens to be 1,692. So you can answer questions like this about files just by kind of composing all of these very small tools that kind of do one thing and do it well. We can also, again, I'll get more into how this works in the regular expression section, but it's not just whale, but also words like whaling and different kinds of verbs that include the word whale. So if we want to see everything that matches whale or whaling, we can use this group right here in the pipe character in the inside of the string there means either an E or ing. And so, whoa. Oh, right, and you have to give grep the capital E command if you don't want to backspace the parentheses. Again, I'll get more into how that all works in the regular expression section. But so there are actually 1,823 instances of whale words in Moby Dick, which is a fun question that we can answer with our command line pipeline here, which is a little program that counts whales. Yeah, so we can use some of the other stuff that we just talked about as well. So for example, maybe we want to, that's a really good piece of information we want to save for later. So what we could also do is we could use the redirect character. So we're going to use greater than to write the whale count to a file. We'll call it whalecount.txt. And so now we have that information for later. And you can combine and remix all of these sorts of pieces. So I think that should give you a lot to play with, hopefully. I've got a little breakdown here of what every piece does, just to kind of review, and then hopefully everyone can get a chance to play around with some of these commands, because they're really fun, I think. So curl-s, again, fetches Moby Dick from Project Gutenberg. It so happens that you get compressed output to your terminal, so you can pipe that to the gunzip commands, which reads from standard in and prints the uncompressed text to standard out. Then we have this little program here that runs sed, which does substitutions. So in this case, backslash capital S means backslash lowercase s means whitespace characters, and the plus means one or more whitespace characters. So that's what it matches. And it replaces one or more whitespace characters with a single new line. And the G means it does that for every whitespace character that it finds, not just the first one. And so if you want to play around with this little sed thingy, you can sort of see what this program does in isolation by piping in some data with echo. So here I have just some 1, 2, 3, whatever. And I can see that, in fact, it works like I expect. This is a really nice thing about pipelines in Unix, is that you can always test what every piece does in isolation before building something really big and complicated. So that's what this little piece of our pipeline does. There's also grep, which filters the output. So remember, before we had all of the words in Moby Dick, and now if we put this grep piece on the end of our pipeline, we only see words with whale in them. And then finally, wc-l will count the number of lines in the output. So we can count the number of times that whale appears. If you want to do things for your script, like maybe prompt for input, there's a command called read that you can use to read a line from standard in and set the result into an environment variable. So you do read line, maybe. That's a good name for a line of input. If you type that in, then you type a message, hit enter, and it's going to save that value into an environment variable called line. So this is a way that in your script, you can do things like prompt for input. So for example, if you had a script that did, I'll just change the script up a bit. So there's a option to echo called -n that doesn't print the new line. So you can do things like have a question or have like a little caret or something with -n, and then it's going to like print it without putting the new line at the end. So if you do that, you could ask like, what is your name? And then read name, and then say echo hello name. If you use an exclamation mark, though, make sure that you quote it properly, because with double quotes in this case, because exclamation marks are a little bit tricky. They actually expand out to be something from the history. So now if I run the script, my name, or sorry, it's going to prompt me for my name. There we go, and it prints out my name. So this is a way. Sometimes you want to read from standard in, although it's less common, but sometimes it makes sense. A lot of the basic utilities don't generally prompt for input interactively. They'll mostly deal with arguments. But for your own scripts, you can do them however you like. Right, so that's just the read command. The main time when I use the read command is actually in conjunction with some other commands that I'd like to talk about. They're also not in the notes, but it's very useful for scripting. I just want to quickly cover a few things like loops and stuff like that, which I don't use a whole lot. Well, actually, I use them all the time, but I don't know if how common they are for other people who use Bash. So why don't I just cover, so we've already seen the watch command. There's something similar to it. If you just remember, so there's a command called true. This gets into something called exit codes, which I'm going to talk about a bit later, but suffice it to say for now, there's a command called true that is truthy. So if we do something like while true, we can like print the date. There's also a command called sleep that will just sit there for however many seconds you specify. And so this command, every second, will print out the date. There's also another kind of loop where if you have a command that will split things by white space, you can loop over all of the values. So we can use the brace expansion for sequences to do something fun there. So if we do for x in like 0 to 10, echo x. In this case, for is going to define a variable called whatever we specified right here. Whoops, whatever we specify right here, and then we can give it a list of things to loop over, and then for every one of those things, we can run this command. And you can put as many commands as you want in here, separated by semicolons or on their own line. And then at the end, you put done, and that tells the loop to be over. So that just, oh, sorry, I did this wrong. You have to put do immediately after for, and then it'll print. These will become more useful once we talk about exit codes and signals a bit later. So. For now, it's just kind of this like nifty little one-liner you can use. The while true thing is really handy if you like have a buggy script, like a server or something that like crashes sometimes, but it's not that important. So you just want it to like restart itself. So you could do like, I do this all the time. I do like while true, do server.js done, and then that'll just, if it crashes, whatever, it just restarts. Pretty handy little trick to do. Another really useful thing to use loops for, especially while loops, is if you have a command like ls-1 that's going to give us every file in a directory, you can pipe into a while loop, which is kind of a little bit strange to think about, but it'll hopefully make sense in a second. So we can combine all of the things that we've already seen to do something really cool. So if you remember the read command, we'll read a line from standard in. So we can read each line of standard in into an environment variable called line, and then do maybe we'll do the wc-l command to print out the number of lines for every file. And maybe we'll also print out the name of the file. So every file should be coming in on standard in. And then we want to do -n so that it doesn't print out a new line. And we also want to put a space in there. There's another little thing, because my ls happens to be configured so that it does, it like puts those stars and things at the end if it's an executable. So I'm actually going to do bin ls to get around my alias. You probably won't have to do this, but in my case I do. A little bit lost in the weeds, but this is a really neat thing that you can do. Hang on. And then you have to put done at the end. There we go. So we see, wc-l also prints out the file after. So I don't like that. I'm going to get rid of that. I'm just going to pipe into, I could pipe into sed and cut off the end, but I'll pipe into awk and print out the first column. There we go. So you don't have to know exactly what this means, but it's just something that you can do if you know a little bit about each of these tools. We can print our own format, file formats and things. And I'll paste that into chat as well, just for some kind of examples to chew on, if nothing else. Again, a relatively advanced use case, but it's kind of, hopefully will give you an idea for how you can sort of string together a lot of these concepts in a coherent way. Vim is an example of a program that's interactive. So this means that it uses ANSI codes, which are special character sequences that do things like control colors. They can also move the cursor around. They can like blink even the text. So here I've got in the notes a little bit of fun things you can try out if you like, just to kind of play around. So if you do this echo command, -e means interpret escape sequences. You can do this hexadecimal escape sequence, x1b, and then print stuff out. So I'll just show you really quick what this does. Yeah, so it's kind of cyan colored text. You can do other colors by changing these values. So like, whoa, that's neat. It sets the background as well. Anyways, sort of what editors like VI and also other interactive programs are doing behind the scenes. More fun stuff and a Wikipedia page that you can play with later if you like. So let's learn Vim. So if you don't already have Vim installed, you probably have at least VI installed. But if you don't have Vim installed, go ahead and install it. Also, on some systems, you'll have to install things like syntax highlighting and all of the fancy features with a package like on a Linux system called Vim Common. So it's good to have that. If you're on a Mac, I think that you're probably already good to go. So why doesn't everybody type Vim? Should see something like this. I have version 7.4 on Debian. So if you try to type, this is what happens. It might take a bit for it to start logging. This is because when you go into VI, you actually start out in this thing called command mode. So to go into insert mode, which is a more familiar kind of editing, you can type I. So then at the bottom, it shows insert with dashes around it. And now you can type like basically like normal. You can even use the arrow keys and things like that, but I'll show you a better way of doing that in a moment. So you can say, hello there, I am in insert mode. So if we want to save this file, we're going to have to give it a file name because we just started Vim without a file name. So to do that, we have to go back into command mode, which you can do by hitting escape. Or you can actually do it with Control-C as well, which is useful if you don't want to like reach all the way up to escape. Although in my system, I have caps lock mapped to escape because I use Vim all the time. So it's very easy for me to hit escape. Anyways, once you're in command mode, you do colon, and then you can do W space the name of the file that you want to save as. So I'll save it as or I'll save it as wow.txt. There we go. And you should see a little message at the bottom similar to that. If you want to quit, now that we've saved our file, you can do in command mode, which you can always get to by hitting escape. You can do :Q, and that exits. If you want to now open that file again, you can do like vi or vim, the name of the file, and you can make a change. If you want to do both saving and quitting in one operation, you can kind of combine those commands by doing :WQ, which saves and quits. If you want to do things like, maybe you made some changes, maybe your cat walked on your keyboard and like put a bunch of characters in your program. I have a cat now that does that a lot. It loves to like stand on my keyboard. If you just want to quit without saving the changes, if you try to do :Q, Vim will tell you, oh, you haven't written your changes out. So you have to tell Vim explicitly :Q!, which is like, I just want to quit. I don't care about the changes. Throw them away, which it does. Now if I open it again, you see that those changes are gone. So to recap, insert mode you can go into by hitting I. There are different ways that I'll go into that you can go into insert mode with like variations, but I to go into insert mode, escape to go from insert mode back into command mode. In command mode, :Q quits, :W writes. So also if you make a change, you can do :W. If you've already specified a file name, then you don't have to specify the file name again. So it saves to the same file. And :WQ writes and quits, :Q quits, :Q ! Quits, discarding changes. Also, if you've typed Vim already and you want to load a file that already exists, you can do :O and the name of that file. There we go.